Hello, children. Today we are going to start a new chapter, that is Earth structure. Okay, talking about Earth structure, we are basically going to talk about the interior of the Earth. And today, in this part, we are going to deal with the temperature, density, and pressure of the Earth's interior. As we all know that there are three realms of the earth. Those are lithosphere, hydrosphere, and atmosphere. And man, we are constantly exploring all these three realms, but very little is known about the interior of the earth, or basically we can say lithosphere. Very little is known about the lithosphere. We know a lot about the hydrosphere, we know a lot about the atmosphere. Like atmosphere, it has various layers of atmosphere, the composition of the atmosphere, the advantages of the different layers of the atmosphere, we know it. Apart from it, regarding the hydrosphere also, we know many things, like the depth of the hydrosphere, we know the deepest ocean, we know, or not only that, we know the topography that lies underneath the hydrosphere, but very less knowledge is there regarding the interior of the earth. And even the surface of the earth is greatly analyzed, we know that. We have different knowledge about the surface of the earth and its composition as well. But geologists, they are not being able to find the information which is in the interior of the earth's surface. They are trying to get the information by digging the boreholes that are there, but the boreholes they have dug is only till 8 kilometers. And when the radius of the earth is seen, it is seen that it is round about 6,378 kilometers. That means we have just dug up to 8 kilometers of the interior of the earth. So very little knowledge is there regarding the interior of the earth. There is no direct information regarding the interior of the earth. Rather, indirect informations are only there, and that is also via the study of the velocity of the earthquake waves. Not only that, the lavas that is emitted by the volcanoes, this gives us the information regarding the interior of the earth. And the change in the temperature, pressure, density of the earth's interior can be estimated by the velocity of the earthquake and by the lavas that has been emitted by the volcanoes. Now we are going to deal with the temperature of the earth. Okay, earth's interior. Now, how do we know that the temperature of the earth's interior, it is very hot? That's because of the presence of the volcanic eruption, as well as the hot springs that are present on the earth's surface. And the temperature increases as we go down deep into the interior of the earth, and the rate at which the temperature increases is 1 degree for every 32 meter of descent. So when we go 32-meter deep into the interior of the earth, there's 1 degree rise in temperature. So in that case, at the distance of round about, at the depth of round about 48 kilometers, the temperature, it will be around 1200 to 2000 degrees centigrade. That way, the raw material, it cannot remain in a solid state at the distance of, or at the depth of 48 kilometers. And if we considered that 1 degree rise in temperature for every 32 meters of descent, then the temperature at the core will be at around 4000 degree or more. But it is estimated by the earth scientists that the rate of increase undergoes a sharp decrease at a greater depth that has been estimated. That's because the upper layer of the atmosphere, it basically has the radioactive mineral that is the thorium and uranium, so which is in abundance till the depth of 100 kilometers. Below that, it is in lesser quantity. So we can summarize the temperature of the earth as, at the depth of 48 kilometers, the temperature is around about 1200 degrees centigrade. At the depth of 400 kilometers, the temperature is around 1500 degrees centigrade. And the temperature at the molten outer core and the solid inner core, at the depth of 5100 kilometers, it is approximately 43 degree centigrade. Sorry, it is 4300 degree centigrade. Now let's discuss about the density of the earth. Okay, earth's interior. So earth, it is not composed of uniform material. If we happen to look into the soil profile, just a few meters of soil profile shows us that it is not made up of uniform material. So how can the depth of earth, which is more than 6,000, which has a radius of more than 6,000 kilometers, can be of a uniform material? So obviously it is not of uniform material. So because it is not of uniform material, that's why its density varies to a great extent. Then the inner layer is heavier than the outer layer. The material of the inner layer of the earth's interior, it is heavier than its outer layer, and the density of the rock, it increases slowly towards the center, or we can say it increases with depth inside the earth's interior, because the area around the center of the earth, it has a heavy metal like nickel and iron is there. That's why the inner core of the earth, it is heavier than the outer layer of the earth. So we can sum up and say that the average density of the earth, it is 5.5, and the surface of the earth, which composes of Sial or silicon and aluminium or graphite, it has a density of 2.7, and the middle layer, which is known as Sima, which constitutes of silicon and magnesium, it has a density of 3, and core, which constitutes of nickel and iron, it's also known as knife, it has a density of more than 16. Now we are going to deal with the pressure in the earth's interior. So pressure, what exactly is pressure? Pressure is the result from a force pressing on an area. If continuous force is exerted in an area, that is known as the pressure, and the pressure increases as we go deeper. So the pressure, as we go deep down into the interior of the earth, the pressure, it starts to increase, and the interior of the earth is under tremendous pressure. That's because of the overlying layer of the earth. The pressure, it is in great quantity when we go to the interior of the earth, and the pressure that is exerted is 1 atmospheric unit equals to the pressure of about 14.7 lb per square inch. So 1 atmospheric pressure means 14.7 lb per square inch. If we look at it that way, then at the depth of 2500 kilometers, the pressure is 1 million atmospheres. Okay, and in that way the pressure will be more at the core. The pressure is estimated to be 3.5 million atmosphere when we go to the interior or in the core. So if such high pressure of a 3.5 million atmosphere is being exerted in the interior of the earth, it will influence the temperature as well as it will influence the physical state of the earth. The composition of the earth, the physical state of the earth, whether it is solid or liquid, that is greatly influenced by the pressure. That's why the areas that is around the center of the earth, probably it acquires the property of a solid, that is due to the enormous pressure from the outside layer. This is all for today, girls. In the next part, we will be dealing with the 3 layers of the atmosphere, that is the crust, mantle, and the core. Take care of yourself. Please study.